Hello and welcome back, dear podcast listeners. We do apologise that it's been a little while, but we've got a crackerjack of an episode to get the latest edition in this series going. On today's episode, we are speaking to Sakthi in Alister, two sterling academics from Reading School of Pharmacy, Pharmacology and Physician Associate. Sakthi and Alister are going to be chatting to us about the importance of cardiovascular health. And we're also going to have a really fascinating chat about snake bites, the way in which their venom can be used and studied to treat other diseases as well. If I could get both of you to please introduce yourselves, tell us what you currently do at Reading and also what your journey through academic life has been. And Alister, I'll go to you first.
Okay, thank you. Well, my name's Aleister McNichol. I'm an associate professor in cardiovascular pharmacology here at the University of Reading. I'm currently researching omega-3 fatty acids and how they interact with particular kinds of proteins on blood vessels called ion channels, and they appear to act like drugs. I'm trying to discover exactly how they work and if we can improve on the natural structure of omega-3 fatty acids to activate those ion channels. In terms of my career as an academic, it's relatively straightforward. Other than the fact, I'm a first generation academic. I went to my local university, which was the University of Edinburgh, and I did pharmacology as a degree. I teach here on the pharmacy school. I'll be honest, I did pharmacology not realizing it was a different course to pharmacy. I actually thought I was doing a pharmacy course and I'd be able to be a pharmacist at the end. And it turned out to be quite a nice bit of serendipity that actually I did really enjoy pharmacology. And I went on, did a PhD at the University of Glasgow, then worked sponsored by the British Heart Foundation at the University of Bath. I then got a fellowship at Bath. And at the end of that, I came over to Reading. And again, I've had research sponsored by the British Heart Foundation since I came over to Reading.
Lovely stuff. Thank you very much, Alister, and Sakthi, over to you.
Yeah, I'm Shivani Yapari. I'm a professor in cardiovascular and venom pharmacology at the University of Reading. So, as my title sounds, I work on two areas. So first, on cardiovascular side, we work on thrombotic diseases, particularly heart attack and strokes. So small blood cells called platelets are the culprits to cause heart attacks and stroke, but they are the ones important to prevent us from excessive bleeding when we get injuries by clotting the blood. But unfortunately, during disease conditions, they are making blood clots within the body, within the blood vessels to cause heart attacks. So we try to understand how these platelets are functioning during disease conditions and how they interact with other cell types within the body to communicate and to alter their function as well under pathological conditions. So on the other side, we work on snake bites, because I come from a very small village in South India. So I've seen lots of snake bite cases and people are still bitten by snakes because we can never eradicate snakes. But the problem is it's causing lots of deaths and disabilities among poor rural communities. And that's why I came over to UK to do my PhD on snake bites. So we still work on snake bites. Particularly, we are focusing on snake bite induced permanent disabilities, how these are developed, what are the mechanisms, and how we can tackle these conditions, because there are 5 times more disabilities than the deaths actually due to snake bites. And we are also developing a diagnostic kit for snake bites, because at the moment we don't have any kit. In India, we work with lots of clinicians who treat snake bite victims to understand the human snake bite spot, because that's a really under-researched area. We are also working lots of local champions and governments and NGOs to improve public awareness about snake bites, because there's a lack of awareness among all rural communities across India and also rest of the world. So that's sort of like my expertise. My academic journey, I did my bachelor's in biochemistry back in India, and then master's in biotechnology. I came out to Reading 17 years ago exactly to do my PhD on snake bites. And then after my PhD, working with John Gibbons on cardiovascular science. So 6 years of postdoc funded by British Heart Foundation. And then in 2015, I was recruited as a lecturer here in pharmacy. And then 2018 became associate professor, and from this year, professor. We are receiving funding from lots of funding agencies, including British Heart Foundation, Royal Society, Physiological Society, and other places as well.
Fantastic. So, Shakti, did you say this is 17 years to the day that you started at Reading?
In a month time, I will be completing 17 years at Reading.
Oh, fantastic.
Yeah.
So yeah, we're so glad to have both of you on the podcast, and obviously you've both got a real wealth of experience that we're really appreciative of asking you about. And this episode we wanted to focus on cardiovascular disease. So just to kick things off with some quite general questions, really, just because the term cardiovascular disease, what does that encompass? Also, if you could say a little bit about what the cardiovascular system is and how it works. If I go to you, Alister, first of all.
Okay, so, well, I suppose in the most simple terms, the cardiovascular system is your heart and circulatory system. So that's the heart, all your blood vessels, all the capillaries. It supplies the blood to all the organs in your body, supplies nutrients, and it also takes away waste products to other organs like the kidneys and liver, where those waste products are filtered and removed from the body. So it's like a system that's contributing to delivering nutrients and also removing waste products. I like to think the simplest way to think about the cardiovascular system is to think of your central heating system at home. You've got a boiler, and that's essentially the pump. You've got all the pipes. And if you like, the radiators are the capillaries, which radiate that energy into the rest of the tissues. And it's a closed system, so it's always pumping the same blood around that system. And just like your heating system at home, the pipes can get all fuzzed up. It gets harder to pump, and eventually you'll get leaks. You'll get some of the pipes breaking, you'll get the boiler breaking, the heart breaking down. So that's cardiovascular disease. Obviously, a gross simplification, just to give some context, if you were to line up all the blood vessels in your body and put them end to end, they'd probably wrap around the world about twice. It's a very intricate and delicate system as well.
And Shakti, perhaps this question would be good for you actually. We hear a lot about cardiovascular disease in the news. As many people will know, it is the leading cause of mortality in the UK. So in our daily lives, how can we improve cardiovascular health? Is it as simple as just good diet and regular exercise, or are there other aspects to it?
Yeah, I mean, as Alister explained, we need to really understand what is cardiovascular system and what it does to the body. So cardiovascular disease is basically an umbrella term to cover all the diseases that occur within your heart and blood vessels. So Alister explained nicely about the cardiovascular system function. It's similar to a radiator and a boiler. So we need a routine maintenance for the system. We can't just assume the system is there and it will work forever. That's a big misconception. So you need to really understand what it is it doing. So you need to do regular servicing, looking after things. Then it will maintain really very well. That's where all the food, the diet, and the exercise comes in. So when we are young, all the muscle and the cells are fastly growing. We have lots of energy. We are doing lots of activities. So whatever you eat, you're going to digest and burn it. So particularly in here in a cold country, we are not going to burn the food as much as that you would do in India, which is a hot country. So whenever I go to India, I lose some weight because I'll sweat all the time, suffocating. It's just literally burning whatever you eat. But here it's not the case. So you need to really understand how much food you need and what you do every day. So again, so whenever I go to India, I see lots and lots of farmers relating to snakebite work. And I never seen a farmer who is working in the field every single day dying from heart attack or stroke. Okay. And they eat quite a lot of food, but they burn everything at 40 degrees Celsius outside temperature every day. So what's happening? Why do you think the cardiovascular diseases are keep increasing? It used to be just a Western disease, but now across the world, even in India, people are dying from heart attack all the time. It's because of the lifestyle we changed. So most people prefer to work on office-based job. We are sitting in the office all day long, 8 to 10 hours. And how much walking we are doing every day during our work. So we need to really understand this concept, and based on the amount of work you do, you need to limit the amount of food you need to eat. In young age, you will digest really very well, which is good. But when we are becoming like a 35, 40, our digestion capacity will also go down. So we need to make sure that we eat only when we are hungry and eat only what we need. You don't have to just keep eating because you love the food. Then obviously it has to get stored somewhere if it can't be utilized. That's when the problem starts. That's when you need to kickstart more exercise. If you want to eat more food, you need to do regular exercise and a healthy diet and limited diet. That's what I would advise.
Yeah, just to follow up on that, I think that Sakthi quite nicely pointed out about the change in our lifestyles. If you like, the Western diet is a high energy diet for people working in the agricultural and heavy industrial eras. So, we are used and habituated to diets that are giving us far too many calories. And those industrial eras have also produced foods for us that fulfill our bodies and desires, I suppose, quite easily. So it's all very tempting. I think the other side, though, is that as well as those lifestyle changes, because of many treatments for cardiovascular diseases, treatments for infections, we're all living a lot longer. And really, I would also argue that the human body isn't really designed to go much past 40 or 50. Things start to go wrong as we age naturally. And part of that is inevitable. But by having exercise, eating well, not smoking, helps maintain our health. And there's actually, this was noted in the 17th century by Thomas Sydenham, who was a physician famous for talking about inflammation, but he also said that a man is only as old as his arteries. And what he noticed was it's the condition of the cardiovascular system, how the arteries look. If they're looking fuzzed up, with plaques in them, then those people also tend to look older. And people with ill health often look older than people in good health, even though they're the same age. And it's often because their cardiovascular systems are in much better shape.
That's fascinating. I think just to want to ask a kind of follow-up question, because both of you really were very correctly and eloquently emphasizing the importance of that regular exercise. What kind of exercise are you recommending? Because you're saying that in the past there was all these considerable number of industrial jobs, and that would, if you want, put quite a strain upon people's bodies. I guess you could say in a way it was almost a healthy strain. So are you essentially recommending that when people think about their exercise, that they should think about doing intense exercise? So something such as regularly walking might not be enough, particularly when you're young. You also need to do that intense exercise. Would that be correct, or would that be incorrect?
Yeah, I think there's a lot of debate about intense exercise at the moment. It's worth noting that the actual government or NHS advice is somewhere around, I think it's about 150 minutes of moderate exercise per week. Now that's moderate. What that means is you'll be a little bit out of breath. And that can be done, not recommended to be done in one session. It's recommended to be done over 3 or 4 or possibly even 5 days a week. Your body does also need a little bit of rest as well. I think there's growing evidence that short bouts of intense activity also give you the similar kind of boosts to your cardiovascular system as moderate exercise over a longer period might do. And that intense exercise, we know we're talking about not really being able to speak easily after you've done a few minutes. So that could be going up 10 flights of stairs or running up 10 flights of stairs, or some very heavy weights very rapidly with lots of repetitions. And they do seem to give benefits to cardiovascular health. I think the bottom line, though, is any amount of exercise is going to be beneficial to your cardiovascular health. And that includes walking. And obviously, as we get older, exercises like walking, which are less intense on our bodies, become more important to make sure we get our exercise time.
And just to add on that, I mean, I've seen some people do quite a lot of exercise, but on the other hand, they eat quite a lot, drink a lot, and smoke. Okay, so again, going back to actual cardiovascular system and what it does, we need to really have some basic understanding of the system and its function. There's no point in eating too much, 6 times a day, and then going to gym for 2 hours and doing intense exercise. So we need to really understand that. So limit the food. So I normally walk the entire White Knights campus, every evening. That's around 10,000 steps, nearly 5 kilometers. That's more than enough for me. It depends on the individual as well and their risk factors. So lots of things associated, but just constant moderate exercise is more than enough, rather than pushing yourself to do like 4 hours exercise once a week and then not controlling your food or drinking or smoking anything. That's not going to be useful. Understand the system, understand the complexity, and maintain a steady pace of what you're doing. That's more than enough.
There's a saying that you can't outrun a bad diet. So it's worth bearing that in mind.
That's very true. And actually, yeah, that links into my follow-up question, because Alister, you were saying about the industrial age, the modern age, we've created foods that kind of fit with, our desires. And I guess a lot of snacks will be fatty and sugary, fatty and salty. And I get the connection between kind of fats or saturated fats and cardiovascular disease. And also, I think smoking adverts, anti-smoking adverts have been quite effective in making that link. I just wanted to ask you what the link between salt and sugar, if there is one, is with that furring up of the arteries that you mentioned before.
Yeah, so I mean, it's actually quite complicated, but I think you're right. For years, people have talked about saturated fat being, as it were, the bad guy, and certain forms in the diet, it can still be bad for you, and you want to have good fats in your diet, polyunsaturated fats as well as saturated fat. But it is perhaps a little overstated sometimes how that affects your cardiovascular system. In terms of things like salt, well, high salt levels will mean that you retain water in your system. That salt, the sodium in there, also retains water in your system, which means you have more blood in your blood vessels, which means you have higher pressure in your blood vessels. So that can really cause high blood pressure in some people. And that then leads to damage to the blood vessels, heart attacks, strokes, and that's where the platelets come in, forming the clots. It is worth bearing in mind that, again, sometimes I believe salt has been overstated. There are certain people who are highly sensitive to salt in their diet. There are some people who can actually tolerate a lot more salt in their diet, or they have other things in their diet that counteract those high levels of salt. But obviously, too much salt is a bad thing. But it's worth bearing in mind too little salt is also a bad thing as well. In terms of the sugars, I know there's a lot of controversy in this area. And if you talk to certain people in science, sugar is the bad guy. Don't worry about fat. It's all sugar. It's terrible. I don't think that's true either. I think there's certain sugars and the way that you ingest sugars and the level of sugar in your blood can be particularly bad. So if you have a bad diet and you have high levels of sugar in your diet, if there's too much sugar in the blood, it's essentially going to cause inflammation, and that's going to cause damage to your cardiovascular system, and again, heart attacks, strokes. Type 2 diabetes is probably what's in there. It's also worth bearing in mind, if you've got too much sugar in your diet, what does your body do? It stores it as fat, so you get more fat, and that fat can also be, you have good fat and bad fat, believe it or not, and your fat also releases signaling molecules into your blood about how your blood vessels and your metabolic system should function. So if you're storing lots and lots of fat, those signals can also go wrong. Then again, it's more pressure, more weight on your body, and again, helps lead to cardiovascular disease.
So that's a really good explanation, thank you. And I think this probably leads quite well into our next question, thinking about inflammation and things like that. But Sakthi, you mentioned in your introduction that you do a lot of research into snake bites, which is really interesting. So could you tell us a bit more about that kind of research and perhaps an explanation of how snake bites impact the body?
Yeah, I mean, it's a really big world, but it's a neglected area. So snakebite is officially a high priority neglected tropical disease at the moment, according to the World Health Organization. So if we look at worldwide, there are over 3,000 species of snakes, but only around 600 are venomous snakes. Rest of them all non-venomous snakes, so we don't have to worry about them. So within these 600 snakes, there are only limited snakes or medically important. They are the one causing most of the bites and most of the deaths and disabilities. But most of these snakes you can classify into two categories. One would be vipers. That's the most important category. That's the one causing most of the bites and deaths and disabilities. Second one will be elapid snakes, which includes, for example, cobra, mamba, king cobra, those type of snakes. So the vipers are predominantly attacking our cardiovascular system. So their venom is composed of lots of toxins that can attack multiple levels within our cardiovascular system and the local tissues, including the skeletal muscle. But if you look at elapid snakes, they are mainly neurotoxins. They will try to attack our nervous system and try to cause paralysis as soon as possible. So there are so many components. Snakes are basically producing venoms to capture their prey, not to kill us. Okay, so instead of secreting saliva, we are secreting saliva to aid in our digestion. So snakes are producing venoms mainly to capture their prey and help for their digestion. So unfortunately, they are using for a defense. So venom is made with like multiple toxins. A single snake venom will have minimum of 25 toxins. Maximum it could have more than 100 different toxins. And the purpose of venom is to arrest the body functions of the prey as quickly as possible. So the prey will die or immobilize, then snake can eat it. So the whole thing will happen in humans when snake bites. So each toxin is working in a different actions. So it can try to attack all over the body in order to arrest our physiological functions as quickly as possible. For example, if we take Russell's viper snake in India, it will cause bleeding from the bite site, massive pain, and then it will randomly start to form blood clots within our system, then affect the kidneys one by one. So that's why they need to get treatment as quickly as possible. So in our lab, we are trying to understand how these toxins are working, which toxins are more important for causing envenomation effects in humans compared to helping in digestion or promoting venom actions, other toxins actions in the body. At the same time, we don't have any diagnostic kits for snake bites at all, except one in Australia, and it doesn't work really very well. So in rural settings where we don't have proper medical facilities, but there might be single primary health center, but there's no mean to find out whether this person is bitten by a venomous snake or non-venomous snake. Even if it is a venomous snake, these snakes will not inject venom all the time. Sometimes if you play with a venomous snake, it will also play with you and it will bite you, but it will not waste its venom. So that's called a dry bite. But these clinicians got no idea to find out whether the person got venom in their body or not. So we need a simple diagnostic tool to find out whether the person has got venom. If they got a venom, we can give some antivenom to them as quickly as possible. So that's one area of work we are doing in the lab. The second thing, we have only antivenom as a treatment in the last 150 years for snake bites. So nothing has been improved in this field. Compared to cardiovascular field or cancer, not any single improvement on this. We improved on the basic understanding of venoms, but not on the therapeutic side. So we need better treatments to treat snake bites. Second thing, antivenom doesn't help to treat your muscle damage around the bite site. So when particularly for vipers, when they bite, the local tissues will get badly affected and they will get necrosis and damage, and that will lead to amputation very quickly if you don't treat on time. So this antivenom cannot penetrate through this affected area. So that's why they can't treat this snakebite induced muscle damage. So we are trying to develop some new treatments for muscle damage, snakebite induced muscle damage, without going for surgical decisions to amputate the limbs. So that's another big area we are working on. And the other thing, lack of public awareness, I mentioned right at the beginning. It's a huge problem. Even in 21st century, people still go for traditional healers. They believe that these people can treat them successfully, and they will waste all their crucial golden hours, we call it, by seeking treatment from these people. But only when the situation gets really worse after 3-4 days, then they rush to hospital, but it's too late to save them, or at least to save their limbs. So that's really important. And the other thing, still people practice so many inappropriate first aids because they are watching movies all the time. And this is what they've been told. If a snake bite happens, immediately take a rotten knife, cut that area, suck the blood, immediately the venom will be filtered. But that's not really true. By doing all of this, you are doing more danger for the victim than saving them. So these things need to be really broken up. So that's why we are trying to burst all these myths in the communities. So it's a really big area, but it's receiving some attention at the moment. In Reading, we got a really big team. Originally, it was just me doing PhD with my supervisor, but at the moment we are seeking support from multiple people. And because these toxins can attack all over the body, you can literally collaborate with anyone in any field. On the other hand, venom can be used as medicine to treat several conditions of humans. When it's a whole as venom, cocktail mixture of toxins, then it's dangerous. But when you isolate individual toxins and find out what it does, it can be used to treat multiple diseases. We can use it to treat cancer. We can use pain, neurological diseases, Alzheimer's, anything in the world. So that's why we call venom as a biotreasure. And there are hundreds of venoms, thousands of venoms, which have never been used in scientific research. We recently started working on invertebrate venoms from scorpions, spiders, tarantula, all those things. So it's a really fascinating area. And the more you hunt, the more you're going to find out.
It was fascinating listening to that, Sakthi. I was just going to add, you mentioned about treating cardiovascular diseases. The first ever, almost like one of our frontline drugs in treatment is called angiotensin converting enzyme inhibitors, and they were originally based on things extracted from snake venom. And indeed, in my laboratory, as I mentioned right back at the beginning, I work on ion channels. Lots of these toxins in snake venom, a lot of these venoms can be very specific for binding or targeting certain ion channels. So we can use it in research to tease out, if you like, as molecular tweezers to eliminate the function of certain ion channels and try and work out how the blood vessels work. So it works in basic science as well as having had applications in medicine.
Exactly. I mean, that's the beauty of this research. It's not just to develop new treatment, new diagnostics for snake bites. So we can use the venoms for medicinal purposes and basic scientific tool, and we can also use that for various disease diagnosis. So that's why it's really important to research on venoms, not just snake venoms, but also invertebrate venoms.
Wow, that is fascinating. I must confess, snakes are definitely my nightmare animal. But really interesting to know the way in which venoms are used for treatment and the huge benefits which they can have. But just to go back slightly, because Sakthi, I know you mentioned at the start, and I thought this was quite an interesting phrase, which is snake bites are a neglected area of research. Why is that? Instinctively, I suppose my response would be, well, it seems like it impacts, if you want, poorer rural communities the worst, whereas it wouldn't impact wealthier urbanized societies nearly so much. Is that the significant reason for this being a neglected area of research, or are there other factors as well?
Yeah, you answered your question very well. Because this is a disease of power and it never came to light properly. So most of these people are living in rural villages. Some of these villages don't even have electricity and road facilities. And if there's a bite, it will never come to light because they never go to hospitals. And the second important thing, because of this, we don't have a proper statistics for this disease. That's a big problem. Worldwide, we are just working with estimates based on the literature. And the actual burden is extremely high. We are working in India with various stakeholders. So we estimated that snake bites in India are likely to be 10 times higher than what's been estimated. Okay, but because we don't have a proper statistics, it never ever received proper attention from health authorities. So that's a big problem. And the other thing, the governments mostly collect statistics from government hospitals. But in countries like in India, predominant amount of people prefer to go to private hospitals because of obvious reasons. But the government doesn't collect statistics from private hospitals. And the private hospitals don't maintain any statistics. So because we don't have a proper statistics and it's a disease of power, it never came to light. So people have been asking WHO to list this as a neglected tropical disease for more than 30 years. And then WHO added it, and then within 2 years, they removed it without discussing with anyone. But now it's back on as a neglected tropical disease, and it's classified as Class A, which is high priority. And they developed a roadmap to reduce snakebite-induced deaths and disabilities by half by 2030. But let's see how much we can achieve.
Okay. I thought as well was quite perceptive is one good way of combating it is you mentioned public awareness, and that hopefully should lead us nicely back onto the next segment, which is yours, Alister. So again, it was interesting for myself and Phil to know that you've got a keen interest in sharing science and scientific findings with schools and the wider public. Why is this so important, do you think? And do you think there's ways in which universities can do this even better in the future?
I mean, it's important on so many levels because ultimately it's the public who fund our science, and often science is done to help the public, particularly in medical sciences. So whether that's funded by the government or funded by the charities like the British Heart Foundation, if you're giving a donation to the British Heart Foundation, then I think it's your responsibility as a scientist to tell the people who've given that money, how am I spending it? Why am I spending it in this way? And hopefully they'll just find it interesting. By talking about your science, it might get more people interested in science and help decide to do science and bring their passion into the laboratory. It's part of the role, I believe, of all scientists, not just academic and university scientists, to go and talk to people in the wider public and try and make what you do understandable to those people. And sometimes when you do put your own research into or frame it in a way that people with no scientific training can understand, it actually helps you understand your own research and why you're doing it. In terms of what universities can do, well, the universities are part of a community. They need to be involved in their local communities. I think it's something that the University of Reading has actually always done, and a lot of universities do it pretty well. We often get a bad rep and we're all up in our ivory towers. But actually the reality is universities are doing a lot to go out and talk to their local communities, their wider communities, to disseminate that research. How can we do it better? I guess it may need more training. I'm trained as a scientist. I'm not trained as a public speaker. So it could be more training for scientists, and universities, learned societies that scientists are members of can all help train people. But at the same time, it takes time and money to do this. So it's also having the time, having funding to be able to go out and talk to people. But on the whole, it's really just about going out, talking to people, and there's nothing magical about science. It's done by human beings. Sometimes things go wrong, and it's important to talk about those things as well.
And we'll put a link to that in the episode description, so you can check that out. But yeah, that's fantastic. And Chris, have you got any final sort of questions before we wrap things up?
No, I think that is everything really. Probably just to say from mine and Phil's perspective, pint of science. If that is happening, we'll definitely be there. Back to you, Phil.
Brilliant. Well, yeah, just to say, thanks so much for coming on, Alister and Sakthi. It's been an absolute pleasure, and I've certainly learnt a lot from all your explanations to our questions. So thanks again.
Excellent. Thank you. Thanks for inviting us. Cheers.
Okay, thanks. Bye.
Bye.
Cheers.
Wow, that was a fantastic episode. I've learnt so much from thinking about the cardiovascular system as like a boiler with radiators that need frequent maintenance, to how under-researched snakebites have been in the past, and the incredible work Sakthi and his team have been doing to help save lives. Next up on the podcast, our guest is doctoral researcher Vicky Boult, who specialises in the conservation of African elephants. Vicky talks us through how she uses meteorological data to help intervene before extreme weather incidents cause harm to these incredible animals. She also tells us about her emotional links with the elephants she has come to know and love over the years. Until then, take care and goodbye.